Hello everyone and welcome to Generative Geek. My name is Vaibhav and we are continuing with our Embeddings with OpenAI series. In the past videos, I have covered topics around getting started with embedding, how to do recommendations using OpenAI embedding, and today in this episode my goal is to continue with the series on embedding. Today we'll talk about zero-shot classification using embeddings with OpenAI. Generally, when we talk about classification, we talk about a supervised ML problem where you make the model learn by making it see several examples of labeled data. So, this model here goes through several examples and then is able to understand that, hey, okay, for an image to have a dog, these are the various features, right? For the object to be a ball, these are the various features, and if those features match, then I'll go out and say, hey, this is a ball, or this is a dog, or this is a cat, or whatever, right? So a model is trained by, and the model sees several examples. Using embedding, what we are going to do today is we'll do classification of hotel reviews where we'll pass several hotel reviews, but we'll not pass any labeled data to the model. And then using by calculating embeddings and then looking at the distances of those embeddings, we will see how with embeddings we can do zero shot classification. Zero shot is there is no the model has had no shot of looking at the examples. It's looking at the examples for the first time, and with that itself it is trying to infer that what is basically the best classification for for this object from the various list of classifications or classes that this object could actually belong to. So like I said, I'm going to use hotel reviews. So what I've done is I've gone ahead and created several hotel reviews, which I'm just going to copy paste. And this is just a list of reviews. So the hotel room was spacious and clean, and the staff was incredibly friendly and accommodating. Now what I did is I just collected these reviews from a certain site. If you already have a data set, you can use that. Otherwise, ask ChatGPT or Claude or whatever GPT tool you use these days to create a reviews list and ask it to make reviews in three classes, right? So what I mean is that when you are asking, or if you are collecting reviews from a certain data set, it's fine. But if you're asking ChatGPT or Claude or any of your Google Gemini to basically build this list for you, ask it to have mixture of reviews which could be positive, neutral, and negative. Then what we are doing is we are just creating a sentiments list. We are saying, hey, the label is positive, the label can be negative, the label can be neutral, right? And now I'll just create what we'll call class descriptions by going through this list. So we'll say class description is a list of sentiments where sentiment label, sorry, I'll just say I'm using list comprehension for this. So sentiment label for sentiment in sentiments, right? So when we do this, we can see what the class descriptions have. It's basically just a list of positive, neutral, and negative. We have these three, and now we have reviews. What we want to go ahead and do is just run embeddings on reviews. So I'll just quickly say that calculate, the first step is calculate embeddings of reviews. Second step is calculate embeddings of class descriptions. Once we have these two embeddings, like we have been doing in lecture 1 and lecture 2, we'll calculate the distance between the two embeddings. We'll find the closest and label the closest. Yeah, so this is what we want to do. So let's use the method that we created last time. If you remember, we had created this method called create embeddings. So I'll say review, make it a Python. Reviews underscore embeddings is equal to create embeddings from text. If you want, I can just quickly show you how this thing looks. Sorry, I pressed the wrong one. Something is wrong. Maybe I'm not. Go to declaration. I'm sorry. Yeah. So we created this embedding from text, which takes an input, which is basically the text that we want to embed, and it's largely a list, right? So if we are passing just a single text, single word, single sentence, then we'll take the 0th element in the response. But what it does is it takes the input, and the model is by default text embedding 3 small. It will call OpenAI's embedding model and create the response dict. We'll then use the embedding within the response dict and pass back a list of embeddings, right? So that's what this method is doing. So I'm just going to call this method and we'll pass it reviews. Next, what we'll do is we'll have our sentiments embedding, or we can say class description, class embeddings, and we'll pass create embeddings from text, and we'll pass class descriptions. Again, both of these reviews and class descriptions here are lists. We'll run this will create the embeddings for us. Once the embeddings are done, the next step is, like I mentioned, we'll calculate the distance between the two embeddings. So we'll create a method called find closest, where what we'll do is we'll take the query vector and we'll take the embeddings, right? Once we take the query vector, or we can say the query vector could be the class vector here, but let's just say query vectors, we'll create distances. We'll make use of we'll make use of scipy.spatial. So let me just import that from scipy.spatial import distance. Distances is an empty list. We'll declare that. And next what we'll do is we'll go through the embeddings that were passed to the method, right? For index comma embedding in enumerate embeddings, what we are doing is we are going to pass through this and we are going to compute the distance of each embedding, each of those hotel review embeddings with the embeddings of the query vector, right? So for index, dist is equal to distance dot cosine query vector and embedding. So we are calculating the distance between these two, and once the distance is calculated, we'll append that distance that we got to the list that we declared earlier. We'll call that distance. And if you remember in the last video, we said because we are going to sort it based on distance, we should also have something like an index, right? So we'll have index here because it will help us go back into the list. And next what we'll do is, once this is done, we'll say closest is equal to minimum of those distances, where the key is, and we'll pass x, where x is nothing but distance, right? So that's the key we just created when we were appending distances. So yeah, distances dot append, not distance dot append. Yeah. So with this, okay, something is wrong. What is wrong? Distances dot append, distance colon dist. Sorry, I should have had. We are creating a dictionary here, so I need to have the curly braces, right? So with this method, the find closest, when it is done, we found the closest. We want to now return closest, right? So this is the closest match that we are returning. Now what we'll do is we'll say for index comma review in enumerate. Now we'll go through each of them, each of the reviews, and we'll start calling this method. So find closest, we'll say review underscore embeddings, and we'll pass it the index, and we'll pass class embeddings, right? So we are passing the class embeddings list, and we are passing one review at a time, and we are saying, hey, of this, which one is it closest to, right? And then we are saying sentiment is equal to sentiments. Sentiments was the list we had earlier, if you remember. This was the labels that we got. Sentiment is sentiments, and we are passing the closest index, and from that we are now going to pick the label. So if you see, once you look at it this way, let's just say if this was found, the index is going to just pick this or maybe this. We now want to read the dictionary and say, hey, what is the label in that, right? So we are going to basically just read this, then call the label, right? This is how you will get the sentiment. Next, let's just print review was classified as sentiment. Yeah. So now when we run it, we'll see the hotel room was spacious and clean, and the staff was incredibly friendly and accommodating, was classified as positive. While the hotel location was convenient, the room was a bit outdated and the Wi-Fi connection was spotty, was classified as negative. Now, when you look at this review, something goes in your mind saying that, hey, is this actually a negative review or is it a neutral review, right? I had an awful experience and that's considered negative. That's perfect. The hotel provided excellent service. That's considered positive. Perfect. I had a terrible stay. Negative. The hotel was decent enough for the price, but don't expect any frills, was classified as neutral. Yeah, makes sense, right? But so what we have done is we just took labels here and we said, hey, which label appears closer to you, model, which label appears closest when you do the embeddings distance calculation, and whatever is closest, we just print that label out, right? So now what I want to do is just want to do more descriptive descriptions of the labels, nothing else, right? So earlier we had this label, we had these sentiments. What I'm now going to do is I'm going to enhance this and maybe just add more keys within this, right? So I'll say, hey, you know what, label positive, let's add another key called description, right? And I'll say this describes a positive hotel review where the user had a great experience, had a good experience, right? So this becomes my description, right? Instead of just saying positive, I'm also now describing what a positive review looks like, right? So next could be again a description of the neutral experience, a neutral hotel review where the user had an average experience. Yeah. And now the negative one, where we can say description a negative hotel review where the user had a bad experience, right? So what I've done is I've just created a more meaningful dictionary. Instead of just saying, hey, this is negative, this is positive, we are now describing what each label is about, right? So again, like we did earlier, what we'll do is this time for class descriptions, instead of looking at just the label, I'll now look at the description, right? So I'll create class descriptions and I'll print them. I'll say my class descriptions are now these. Earlier when we did, our class description was positive, neutral, negative. Now it's more detailed in a way. We are still not training the model on the labels. We are just describing the label a little more, right? So with this done, next steps are the same. What we'll do is, if you remember, we need to now calculate the embeddings. We already have the reviews embedding. I'm just going to calculate the class embeddings again. And once we have the class embeddings, we now need to compute distances between these two embeddings, right? The reviews embedding and the class description embeddings. And rest of the find closest, this method remains the same. We'll again loop through this. We'll just say, so we created that method earlier. What we are now doing is we are taking reviews embedding. We're going each review by review, and we are passing class embeddings. And we're saying, hey, of all of these class embeddings, so this class embeddings, if you remember from our earlier lecture, has to be a list, right? So class embeddings, if you do a type on it, type on class embeddings, it's a list. And if you just do a type, and if you do a len on class embeddings, it has to be 3, right? So there are, like, it has embeddings of 3 vectors in a list. It has 3 vectors in a list. And what we are now doing is, when we call find closest, we are trying to find of these 3, which one is closest to this specific embedding, right? So we pick review by review. We have the embeddings of those reviews. We are calculating distance of that embedding, of the review embedding, with that specific label description embedding, right? And saying, hey, which one was closest? My challenge, and why I'm doing this right now, is that if you look at this review, the second one, I had an awful, while the hotel location was convenient, the room was a bit outdated and the Wi-Fi connection was spotty. Is maybe an average experience. The reviewer is still saying the hotel location is very convenient, right? It's not an all-out negative review. So I'm just trying to see, will the model reclassify this if I make the label description more descriptive, and instead of just taking embeddings of positive, negative, and neutral, I take embedding of this text, right? Will it be able to find meaning, right? So let's just see. Now if you look at it, the hotel room was spacious and clean, was tagged positive. Now if you look at it, while the hotel location was convenient, the room was a bit outdated, was classified as neutral. Now this is neutral. This is no more the last one was earlier, that was neutral. It's still neutral here, right? So the second one was a case where we found that this was getting tagged as negative. Is now the model is saying it's neutral. It's not a negative review. Let's just also see, the hotel staff was helpful, was tagged neutral. The hotel staff was helpful, but the room was smaller, leading to a noisy light, was classified as negative. So this was earlier classified as negative. Now it has come back to neutral, right? The hotel staff was, just because the hotel staff was helpful, the reviewer the model believes it's more closer to an average rating classification than a negative classification. So guys, this was it. This was how you basically take your reviews. What we did, I'll just quickly recap. We had a list of reviews. You can get this list from wherever you wish. Maybe scrape, maybe go to a data set, or ask ChatGPT to build a reviews list for you. Idea is you bring some list of reviews, right? From some list of which you want to do classification. Then you tell the class labels. You create a class descriptions list, which is basically just a list of labels, right? And then you calculate embeddings of these two. You calculate embeddings of reviews, and you calculate embeddings of the class descriptions. Next, we build a method which will take 2 embeddings and calculate their distances, and whichever one is the closest, it will return the closest, right? Once you return the closest, once you have this method, we'll go through each review, and we'll pass it the embeddings and the class embeddings, right? We'll pass these 2 embeddings to the closest method, and we'll then say, hey, what was the classification? What was the sentiment? What was the classification? Whatever is the classification, we'll print that. Next, we'll go through the results, and we might find that something that was probably neutral is getting tagged as negative, right? So what we'll do now is we then created more descriptive labels, not labels, but we added descriptions to the labels, right? That what is a positive review, what is a neutral review, what is a negative review, and then we took embeddings of these descriptions, and in the hope that, with the hope that the descriptions are going to help the model find more meaning, so more context, more similarity. And then we ran again the same thing. We ran each embedding against each class embedding, and this time we saw that, earlier something that was getting tagged as negative is now neutral, because our review was very clear, our description was very clear, that a neutral hotel review is where the user had an average experience. So this was it, guys. I hope you learned something today. This is just a humble attempt. I'm trying to put as many videos as I can as time allows. If you liked my effort, if you liked something, if you learned something, do press the like button. Thank you so much, and do subscribe. Thank you so much for your time.